connected in series. Is that clear? Is that clear? Yeah. Connected in series to the branch where you want to measure the current. In our circuit we had only one branch, so obviously you could connect it anywhere. But if you have 2 or 3 branches and you want to find the current through one of them, you put it in series to that. Okay? And then you need to know that the current that you measure will always be slightly less than the actual value. Okay? So the actual value is 1 amps. We measured 0.67 initially. We fixed it kind of, but still we measured 0.99, right? So it's going to be a bit less than the actual value. And also that you can fix it by adding a small resistor in parallel to the D'Arch-Novel meter. Okay? And this small resistor that's added is generally called shunt resistor. Okay? So if you ever hear the word, it's just the resistor that's added in parallel. It's nothing else. It's just a shunt resistor. Is just a name used. Shunt. Can you see that? Can you see that? Okay. Shunt resistor is just a name that's used when you add something in parallel. Okay? And generally for ammeters, we say that we have a shunt resistor of 1 ohms or something that's very good. Is that clear?
If you have an ammeter with the resistor built in, will it be rated at the equivalent resistance or at the 50 ohms?
It would be rated as equivalent resistance. Yes. Now the equivalent resistance is not 1 ohm anymore. This is just the rating of the D'Arch-Novel meter. Most probably, as I said, it would not be rated. The D'Arch-Novel meter is going to be rated as milliamp some resistance. Okay? An ammeter, in the data sheet, you will definitely find the equivalent resistance of it. But generally, it's going to be rated as this much is the tolerance limit of it. Or let's say 5 to 10% plus or minus is what you're going to read. Okay? I don't know how you will actually read plus. You most probably will always read less current than you have. Somehow that's how we read it. Okay? Is that clear? Okay, so that's about the ammeter. Just like the ammeter, you have a voltmeter to measure what?
Voltage.
Voltage, of course. And we have the same circuit over here. And now I ask you, what is the voltage across the 40 ohms? What is the voltage across the 40 ohms?
40 volts.
40 volts. It is I times R. I is what? 1 amp, 100 divided by I is 100 divided by the total resistance. I times R. R is your 40 ohms. So it's 40 volts, right? So once again, we knew that the resistance was 40 ohms, so we can find that it's supposed to be 40 volts. But if we didn't know what the resistance was, we would have to measure it, right? So now I want to measure the voltage across the 40 ohms, and I want to measure 40 volts, okay? How do I do that? Where do I connect that D'Arch-Novel meter I have so as to measure this 40 volt? You would connect it in parallel to the 40 ohm, right? We always say voltage across the two terminals of the device, right? We always speak of it as a voltage across, so it would have to be connected over here. That is the 50, right? And now, what is the voltage across the 40 ohm, or between terminals A and B. Is it still 40 volts or has it changed? We said that when we were talking about potentiometer, right? When you added a bulb, did the voltage change?
Yeah.
It changed, right? We just did that, right? So now the voltage has changed, so let us see what is the change in the voltage. So for that, we have to start off where? Where do we start off if we have to find the voltage?
Find the equivalent resistance.
Yes, you find the equivalent resistance. So now I have the 60 ohm as it is, and I have the 40 in parallel to 50. What is the equivalent of 40 parallel to 50? It's going to be less than 40 and most probably closer to 20 something. Because what is 50?
0.22.
22 ohms. What is 50 parallel to 50? 25. So 40 parallel to 50 has to be something close to that, right? You can check your answers intuitively to make sure that you didn't plug it in wrong inside your calculator. So you have 22 ohms over there. And we have. So now what is the voltage across the 22 ohms? Or basically the 40 ohms. What is the voltage? It would be nice if you actually take out your calculators and plug it in for me and let me know.
27 volts.
27 volts.
It would be 100 volts divided by the total resistance, that's 60 plus 22 times 22 ohms. And that is, how much you said? 27?
27.
So we started off with a 40 volt, right? And now we have how much? We have 27. So do we have an error in the reading?
Yes.
We definitely do. And how much is the error? It is the true value of the voltage minus the measured value. Once again, you can see that the measured value is less than the true value, right? So that's 40 minus 27, that is how much? 13. 13. Okay? Have 13 volts error in a 40 volt reading. Is that kind of acceptable? I wouldn't think so. So for my 40 volt bulb, or if I check the voltage across a bulb and I find that it's 27 when I'm actually supposed to read 40, I don't think I'm going to like it, right? So we want to fix it once again, of course. And what was the initial reason that we had this error? What caused the error?
The extra 50.
Yes, the extra 50, right? So initially, how was it? When we were talking about the 40 ohms and we said that there was 40 volts, how did we talk about it? We didn't have anything over here, right? We just said, what is the voltage between A and B? So that means how much was the resistance? Infinite resistance, right? We had infinite resistance between these two terminals when we were actually ideally measuring it, right? So now we added something that 50 and we have an error. So now what should I do to this 50 in order to reduce the error? You want to increase the resistance, right? You want to make it as close to infinity so that we have as less error as we can have, right? So we want to make it closer to infinity. Of course, we cannot get something close enough to infinity. We'll make it as large as possible, right? And how do you make it large?
Series.
You add a big resistor in series, right? By adding a big resistance in series, we could make the resistance of this meter actually very large. So now I have this 50 ohm resistor or 50 ohm meter. That's my meter, okay? And I add a very large resistor. How much do you want to add? Infinity is not an option. You have to actually build it, right? So something that's large, 1,000 would be good enough, okay? If you can get your hands on something bigger. Actually, 1,000 is not a very big resistor. We have, 10, 50 kilo ohms and so forth, okay? You can add anything. We'll just add 1,000 for our testing today, okay? So now we have a 1000 ohm resistor in series with 50. What is the total resistance of that meter? 1050. So again I have 60 ohm resistor. I have my 40 ohm resistor. And now I have how much? 1050 in parallel to this 40 ohm. That's a lot better than my 50 ohm resistor that I had initially, right? So now what is the voltage between A and B? Where do we start? Where do we start?
Equivalent resistance.
Yes, you try to find the equivalent resistance. And what is the equivalent of 40 in parallel to 1050? It's going to be something close to 40. It's something less than 40, obviously, right? 40 parallel to 1050 has to be less than 40, and it's going to be something close to 40 actually. Okay? So it's 38.5. Now what is the voltage?
39.
Thank you. You have 100 volt battery divided by the total resistance, that's 60 plus 38.5, that's your current. V over R is your current, right? Times the resistance, that's 38.5 ohms. That comes out to be what?
39.
39. Okay. So now we have 39 volts across it. Okay. So what's the error now? What's the error now? 1 volt. Now your error is only 1 volt. I think I'm fine with it, but if you want to reduce the error, how would you go about it? You would, sorry? You would use a larger resistor. Instead of this 1000, if you could get a 10,000 or 50,000, which is not that hard to find actually, okay? So if you could put something more bigger, you would have less error, okay? You could go home and give it a try with a 10,000 to get a better answer, okay? So again, for a voltmeter, just like for the ammeter, we have some points. I'll just write it down so that you can take it down on your piece of paper. Voltmeter is always connected in parallel. Parallel to the element you're measuring the voltage across. Okay? So in our case, we were trying to measure the voltage across the 40 ohm. So we kept it in parallel to the 40 ohm. If you were to measure it across the 60 ohm, where would you keep it? Across the 60 ohm, obviously. Okay. And once again, just as in the case of the current, the voltage measured is always going to be slightly less than the true voltage. It's always going to be slightly less, right? Instead of 40, we measured 39, right? Even after fixing everything. And you can fix it by adding what? Adding a large resistor in series. So once again, the voltmeters that we will get will have this series resistor added onto it. And once you get the device, it will be actually fixed or corrected for this. Okay? So if you see a voltmeter that has a very low resistance, is that a good voltmeter or a bad one? It's a bad one. You need to be able to see these things in your, in your testing, whenever you're using it at any point of your time. You need to know how to connect a voltmeter, how to connect an ammeter, and whether the voltmeter and ammeter is good one or not. Okay? You'll see actually many of the electrical engineers also make the mistake of connecting an ammeter in parallel and not saying that we got 0.1 amps instead of actually getting 1 amps. Something is wrong with the ammeter. It's not exactly not wrong with the ammeter. Okay? It's your mistake in connecting it. Okay? You need to make sure of that. And we're not going to be looking at an ammeter because, as I said, connecting an ammeter requires me to actually take off my circuit. Okay? I said, right? An ammeter has to be connected in series and you have to take off the circuit and put it in between. So we're not doing that. Help me out. So we saw this one last day, right? Just pull that for me. We saw that this was a potentiometer, right? And I had it connected to a battery. We saw that last day. And if I just turn this, when I turn this potentiometer, the bulb glows brighter and low. I mean, it dims on because of the difference in the voltage, right? And so, if I connect this voltmeter, this is a voltmeter out here. It's a DC voltmeter, measures DC voltage. If I connect this voltmeter, can you just put that here? Between the two ends of this bulb, okay? You should see that the, the needle actually deflects, right? And it should deflect more if I have more voltage across the bulb, right? And it should deflect less if I have less voltage, right? So we just start up there and we go here. So I can't see it, I'm just, am I going the right? Okay.
There we go, it's strong.
Okay, so the voltage is dropped, I believe.
Yeah,
Okay, and you should see the needle moving up. Okay, that's what is your, there's some kind of open somewhere.
Yeah.
It's not a very good circuit. That's why you need to know how to fix these things, you see. Okay, so that's about it. You just need to know how the diastolic meter works. Okay, it moves because there's a battery connected to it, and it deflects based on how much voltage is connected. Okay, I think that's actually kind of good enough for today. Ohm meter, we could start on ohm meter, but actually I wanted to do it along with Wheatstone because an ohm meter is going to measure what? Ohms, resistance of course. And there's another instrument called Wheatstone bridge which also measures resistance. Okay, so we'll do both of them together. I'll just tell you this much, which I forgot in between actually. A voltmeter is represented like this. It always will have a plus and minus. So you connect the positive end of that voltmeter here, connect the negative end to the ground. Okay, so it's going to be represented like this: a circle and a V within it. It's not a voltage source when you see this. It's a voltmeter. Okay. And again, an ammeter is going to be represented like this. It means it's an ammeter, and when you see this, it most probably means the diastolic meter along with the shunt. Okay, it's both of them together combines to give you this.
Is this called a shunt as well? The shunt?
No. Shunt is only for a parallel resistor. Okay.
Does this have a name?
It's just a series resistor.
series
No, it
resistor.
doesn't have another fancy name. Okay, let's get another. Thank you. And make sure you practice the homework problems, homework 2, and the sample problems that I gave you. Okay? If you have any questions, you'll find
That's for every day.
them.